Hi, everyone. I'm Richard Piacentini, President and CEO for Phipps Conservatory and Botanical Gardens, and welcome to the 12th webinar of the Climate Toolkit. Before we get started, I want to just welcome everybody. It's a pleasure to have all of you with us. And I'm also very pleased to report that the Climate Toolkit now has 156 institutions serving more than 76 million annual visitors in 14 countries around the world, and with more joining each week. So if you're not, your institution is currently not a member, we would definitely encourage you to do so. Our conversation during the next hour will center around buildings, energy, and decarbonization. We'll first hear from Architecture 2030 about the necessary frameworks we must all implement to rapidly transform the built environment from the major emitter of greenhouse gases to a central solution to the climate crisis, followed by a presentation from Phipps on redefining building project return on investment to prioritize regenerative design. And now I'd like to send it over to Andrew Lample, our Climate Toolkit manager, who will moderate our discussion and introduce our guest speakers. Andrew.
Thank you, Richard. I also wanted to share that Museum of Contemporary Art, who were originally scheduled to speak, are unable to be with us today, but we do hope to showcase their work at a future session. As the presentation begins, please use the Zoom chat function to enter questions, which we will answer during a Q&A panel discussion after the talks have concluded. And now I'd like to begin the webinar with our first speaker, Vincent Martinez, President and Chief Operating Officer of Architecture 2030. Vince?
Thank you, Andrew. I really appreciate the opportunity to be here. Thank you, Richard. So I'm going to give you an overview of some of the information about the built environment, both projections around its global growth and also around opportunities for reducing its emission impact. So I'll go ahead and get started here. And you should, Andrew, see my screen appropriately as we practiced? Great. Okay. So I'm going to focus on some global design principles for people and planet. And first, I wanted to start off with some of the global growth statistics. By 2050, the world's population is expected to increase by nearly 2 billion people, from the current 1.8 billion to about 9.7 billion in 2050. And we're not expected to peak in terms of global population until the mid-2080s, around 10.4 billion people. So if we're adding all of these people to this planet, what about the places where these folks live, work, play, and the infrastructure associated with that? Well, the projections are that by 2060, not too far in the future here, global building floor area is projected to increase by about 2.4 trillion square feet, about 223 billion square meters. And that's the equivalent of adding this building stock of this New York City, all 5 boroughs, to the planet every month. For the next 40 years, essentially. I was just at a global forum in Paris, and the conversation there, it's about a city of Paris a week. It's about the nation of Japan every month. So it is quite a dramatic amount of building stock that is projected to house all of these folks. And this includes schools, housing, offices. This is everything. Now, the global building stock currently is about 2.4 trillion square feet. So we're essentially adding another entire planet, everything we built since the dawn of the Industrial Revolution, to this planet in the next 4 decades. Now, in terms of the infrastructure associated with those buildings as well, the UN Environment Program notes that in 2050, the amount of infrastructure that we're projected to have, 3/4 of that has yet to be built. So when we're talking about doubling the building stock, we're essentially talking about close to quadrupling the infrastructure. And now infrastructure here means a variety of different things. It can include anything from bridges and roads and rails to communications and telecom. So infrastructure here is a larger category, but it gives you a sense of the scale in which this global projections for accommodating a growing population. Now, we know that the built environment is responsible for about 42% of global CO2 emissions. These are energy and process-related emissions, so they don't include things like deforestation or agriculture, but anything that comes out of the of energy sources. And we can see here that about 27% of that is building operations. And you all operate facilities. You're familiar with heating, lighting, cooling, hot water, plug loads in those facilities. That's the building operations. And this is annually. This is every year. All of the buildings that are currently around today emit about that much emissions. Now, if we also look that just two materials, cement, iron, and steel, I call those one, but we can call them two, and aluminum are responsible for another 15% of global emissions just as they're used in the built environment. There's a little bit more steel that's used in transportation and other areas, but about half of the steel and concrete is used in buildings. You're familiar with that for your facilities, but about half of the iron and steel and cement is also used in infrastructure. And those are the roads, rails, bridges, that we use to get around and move from building to building, including infrastructure projects. So it's a pretty significant piece. We also know that this doesn't include all the other building materials and infrastructure materials that are used. We're not talking about the plastics that are in our buildings. We're not talking about asphalt, for example, in our infrastructure. We also know that the built environment, the way that we plan and design our cities, influences how folks get around that transportation emissions portion of the pie. So we recognize that the built environment's impact are actually considerably more than that 42%. And certainly how we plan, design, and construct that built environment over the next 4 decades very well may determine the fate of the planet. It's a huge amount of the carbon budget that will be taken up by global infrastructure and building growth. So how are we supposed to get to a zero carbon built environment? Well, we think that step one is just good design, planning, and construction. And we think you can get pretty far along the pathway there just through better design, low cost, no cost, and in many cases, cost savings opportunities. And the rest of the way, we'll need renewable, fossil fuel-free energy sources to power our buildings and our infrastructure and create our materials. So in step one, planning, design, and construction, including no on-site fossil fuels for both construction and operation. Again, we think about 70 to 80%, and we've seen this in a variety of building and infrastructure projects by just better design, including things at the planning scale like transit-oriented developments and walkable communities, carbon sequestering sites, local food production. These are great options for designing systems differently. And then we go down into the building focused pieces like reusing existing buildings and renovating them, the orientation and the shape of the building, the color, passive heating strategies and cooling strategies, daylighting and natural ventilation systems, and then all the way to bio-based materials and carbon sequestering structures. We have a good understanding of the technologies and the systems and the design processes that can get us quite a bit way there. And again, these are low cost, no cost, and cost savings options. And then you have the renewables, which we're seeing a proliferation of, including wind and solar, geothermal, tidal energy. There's just a proliferation of renewable energy sources. It's growing almost exponentially in every couple of years. So it's really incredible to see that progress. But first, we need to get the energy consumption down using design and planning strategies. Now, we've recognized that these strategies are going to look different all over the world. And we've actually embarked on a project about a decade ago called the 2030 Palette that recognized a lot of these strategies around regional issues, city and town planning, districts strategies, as well as working on sustainable sites, all the way down to laying out buildings, building strategies, sourcing and selecting building materials for construction and infrastructure. And what we tried to focus on here are the principles. What are the strategies around natural ventilation? What are the strategies around solar shading? And then how are they being applied in different local vernaculars with local materials all over the world? We have a history in the modern movement that started in the 1920s in Europe that was denoted the international style. And that's why we have buildings that look the same all over the world today and are sort of can be placed these glass boxes everywhere. We recognize that the future is really looking back at the past about a lot of the ways that we designed and understood how we lived with nature, how we lived with the environment, and then found local materials that were inherently lower carbon in their manufacturing and construction. And these are opportunities to learn from those principles. So I'm going to dive into what we can do around broader principles now that are being agreed upon at an international level. I mentioned that I was in Paris last week for a global forum on buildings and climate, and the French government and the United Nations Environment Program launched a set of principles. They're not exactly the ones that I'll show here, but we were very similar in alignment about what we're talking about this new paradigm shift looks like for a postmodern movement of planning and design of buildings and the infrastructure. So First, I'll start with urban planning principles. And these are really important because they set the stage for where buildings even exist and how we move around and get around in our cities. So first off, the five urban planning principles: establishing growth boundaries and planning for compact development, infill, and creating resilient developments that mitigate the impacts of climate change. So part of this is ensuring we don't take up more land than is necessary for the global development, those projections that we talked about, and then associated infrastructure in order to move goods and services and people. And all of this has both transportation emission reduction opportunities, but also embodied carbon, including the materials and the construction practices. We need to make better use of the existing infrastructure that we already have. Second principle is creating and restoring natural environments, urban forests, living shorelines, protecting farmland and historic sites, and creating urban parks. We know that we need to start leading with nature, and that providing access to natural environments not only provides us with ecosystem services, but enhances our well-being. It contains water, it lowers heat island effect. These are really important principles for recognizing not just on the regional planning scale, but also in the building space. Third urban planning principle is planning for transit-oriented developments. And this is to align with density, locate residential, commercial, and recreational areas near transit hubs. We need to ensure free and efficient circulation, but we don't need to be tied specifically to vehicles and roads. There's a variety of mobility options that come at different forms and different scales, and transit-oriented developments help support those. Fourth urban planning principle is creating an inclusive mixed-use neighborhoods that combine residences, buildings, workplaces, and civic services. Sometimes you might hear about this as being called like the 15-minute city, where all the services are available within a 15-minute walking distance. And then we have those in those transit-oriented developments. We know that a lot of our transportation issues and emissions are associated with single-use development. You go from a residential neighborhood to a commercial neighborhood, and we have the traffic associated with that, but we also have the emissions. So looking to create these mixed use and vibrant neighborhoods is a really critical strategy for reducing transportation emissions, but it also creates promotion of health and culture in communities. And then finally, the fifth urban planning principle is planning for small blocks, human scale streets, walking, and biking. Again, we need to consider the human scale. We're building cities for humans. And how do we design these cities and streets for people and not the automobile? So I'm going to go over those urban planning principles again. So we have growth boundaries and compact resilient developments, natural environments, open parklands, transit-oriented developments and transit mobility, inclusive mixed-use neighborhoods, human scale streets, blocks, and walking and biking. We think that together with all of these principles, we can really reduce emissions, and we can create more vibrant neighborhoods, promote culture, and increase livelihoods and health. Now let's look at the planning, the architecture and design principles. There's also 5 here. This we'll talk about a little bit towards the end around the revised building and energy framework for the Climate Toolkit, particularly around electrifying and incorporating passive solar heating, cooling, daylighting, and natural ventilation, and then integrating on-site and off-site renewable energy, all while using no fossil fuels on-site. We know we need to zero out building operations, and we need to start with passive systems. The second architecture and design principle is reuse, adaptation, renovation, and restoring buildings instead of constructing new ones. There's a great quote by one of our senior fellows that the greenest building is the one that is already built. And a recognition of this has come in the US particularly, where half of architectural buildings now are for existing building projects. We are actually looking at doing more renovations than we are about building new projects now, which is really exciting from a climate perspective, but also a community. This is both an embodied carbon strategy, the materials use that we're saving by renovating existing buildings instead of building new ones, and then our operational emission reductions opportunities by improving the efficiency and decarbonizing the operations of existing buildings. But their benefits are much more beyond emissions. Building reuse also supports revitalizing existing neighborhoods, creates local jobs, it builds financial equity, It also increases neighborhood resilience and empowers communities. And we know that, particularly in the United States, that investment in communities have been subjected to historic discrimination. And there's a potential here for sustainable and equitable climate solutions that have meaningful economic outcomes for those of our most impacted in our communities, because these are inherently local. You're not importing or exporting jobs across the world when you're renovating buildings in your own town. The third architecture and design principle is creating carbon sequestering landscapes and infrastructures, essentially paving less and planting more. And this is a really impactful strategy, because we know that these solutions have relatively been underutilized, but they provide a ton of benefit. Landscape architecture has long embraced many of these solutions, but they're now gaining quite a bit of wider recognition among the architecture and engineering organizations. Some folks call this rewilding in cities. And according to the Nature Conservancy, these ecological interventions can provide up to 30% of the cost-effective carbon drawdown that's needed by 2030. So we know that nature-based solutions in the built environment support not just climate mitigation, but enable co-benefits like human and environmental health, economic prosperity, and biodiversity, of which we're also in a biodiversity crisis in the world. The fourth architecture and design principle is designing buildings for disassembly, so we can reuse most of their materials and optimize the structure and use locally sourced nature-based materials. Now, we talked a little bit briefly about reusing existing buildings, and that's first and foremost, essentially reusing cities, reusing buildings, and now reusing materials. And part of that is making sure that we're designing things to come apart and be reused. And we see this as a movement, not just in the built environment, but in many other spaces, because materials are precious and we need to stop having a use and waste mentality and bring it back into the life cycle in a circular economy approach. And bio-based materials also provides an opportunity to store carbon in our existing built environment. And finally, the fifth architecture and design principle is mapping the present and future climate impacts and designing to mitigate their impacts. We know that we're already experiencing dramatic climate impacts. They're already here, and we need to anticipate them, map them, and design for them. We can't be thinking about the current state of the climate. We have to think about the future state, and we need to be designing for resilience for both for flooding, drought, sea level rise, heat waves, and more. So I'm going to go through those architecture and design principles one more time. First, again, electrify buildings, apply passive systems, and apply renewable energy. Reuse, adapt, renovate, and restore buildings. Carbon sequestering landscapes and infrastructure. Building disassembly, optimize the structure and nature-based materials. And finally, map and design for climate impacts.
Yeah.
How do I call somebody with their?
So I'm going to highlight back to those projections again about essentially doubling the global building stock in the next 4 decades, quadrupling the infrastructure. And I want to stress that these statistics are extremely intimidating. And they are just projections. If we reuse a lot of our buildings, if we reuse our infrastructure, we can start to reduce some of this. But we do have growing populations all over the world that will need adequate housing, spaces to live, work, and play. And we have to really reconsider this as an opportunity. It's certainly a challenge, but if we apply the principles in planning and in building design and architecture, we have an opportunity to enhance cities, lead with green infrastructure over gray, and expand our need for still meeting our housing needs and our service needs. So this is really an important effort to start now before much of the global built environment is built. So I'd like to just again stress that much of this has already been captured. We know what this looks like. We have pockets of the future that are alive and thriving in the present. We just need to spread these principles far and wide, let them take root in local communities, and that they should have place-based local vernacular, culturally appropriate applications. This is not a new international style from the modern movement, the way we transformed the built environment over the last 100 years. But this is an opportunity to really reinvent a sustainable future and meet the urgent challenges of our time. So I'd like to just end. I was asked to go over some of the revised Climate Toolkit actions for buildings and energy that we help to support and better understanding this. I'll say that these actually align very well with a recent initiative from the White House in the US on a zero emissions building definition. They call it phase 1 because they're really just looking here at building operations, but they will continue to expand and talk about embodied carbon of those emissions associated with the materials development, extraction, production, and use, as well as construction emissions. And so that's coming up. There's actually a meeting in DC here in a couple weeks. But this is on the operation side, so it aligns very well. This is from the Climate Toolkit. First off is meeting your nation's Paris Agreement targets for CO2 emission reduction. We see that each country that signed on the Paris Agreement has their own nationally determined contributions, and many and more, including buildings, as part of their NDCs. And so this is an important framework to make sure that you're meeting that country's target. We mentioned this in the principles, but making sure we derive power solely from 100% clean renewable energy. And that can be generated either on site of your facilities, on the building, or on the parking lots or in the campuses, or it can be procured through market mechanisms. There's a pretty robust market mechanism approach for procurement of renewable energy that ensures we have a variety of things to make sure we have additionality and longevity of our renewable energy stock. I mentioned this one earlier. We also have to ensure that we eliminate all fossil fuel combustions to heat the buildings. We know that we essentially have a bunch of little mini power plants that emit emissions in each building. And we know that we have the technologies now in which we can move to electric systems to heat and cool our buildings. And there is an exception here in the Climate Toolkit for backup generators. Battery technology on that front is still under development in order to make that cost effective, and there might still be a need for fossil fuels in the interim for backup generation. Next up is to make sure all new buildings meet the latest energy efficiency standards. We're very fortunate in this country that we have international energy codes that are very, very efficient. Folks work on a consensus-based process for over 3 years in each cycle to produce very efficient and adaptable codes. This is the International Energy Conservation Code. ASHRAE puts out standards. ASHRAE is the American Society of Heating and Refrigerating and Air Conditioning Engineers. And there's also standards from certification bodies like the International Living in Future Institute that reference energy efficiency. What should we expect new buildings to come in terms of their energy performance? So meeting those latest standards, regardless of whether or not your local state or government has adopted them. And then finally, ensuring that existing buildings achieve energy use intensity, essentially the amount of energy you use per square foot, which is a normalization protocol, of 35% below the median. We know that existing buildings need to ratchet up their performance over time. We're even seeing building energy policy that heads in this direction called building performance standards. But in order to be a signatory to the toolkit, you're looking at a leadership group that is already making sure that they're well below the median. So with that, I'd like to close, and I'm excited for the Phipps presentation, and then we'll to have a discussion with all of you.
Thank you very much, everybody. And thank you, Vince. That was fantastic. Next, I'd like to reintroduce Richard Piacentini, President and CEO of Phipps Conservatory. Richard?
Thank you, Andrew, and thank you, Vincent. That was really fantastic. I'm going to just start with sharing my screen right now, so just give me a minute to switch. Okay, so it was a great presentation by Vincent about some of the things we need to be thinking about as we move forward with addressing climate change and reducing energy use in buildings. So how do we justify the financial commitment to embrace some of the strategies that Vincent talked about? And it really comes down to this idea of how do you measure success? And I'd like to tell you a little bit about some of the experience that we've had at Phipps Conservatory and Botanical Gardens in Pittsburgh. This is a picture of our campus. We're located in the southwest portion of Pennsylvania. And the area that I'd like to focus on, or where the experience that we gathered, is from behind the conservatory in what used to be an old public works yard, which now houses 3 zero-energy buildings. And the one building that I really like to focus on is this one that you see circled in red here, which is our Center for Sustainable Landscapes, which opened in December of 2010. And it was built to meet the highest standards of building efficiency, energy efficiency, as well as the highest standards for human and ecological health. And it's achieved all of these certifications that you see here, the Living Building Challenge, LEED Platinum. It was the first WELL Platinum building, which is related to how buildings affect human health. It was the first CITES Platinum building, which is related to the landscape. It was the first building in the USA to get BREEAM Outstanding for operations and maintenance, which looks at how does the building operate after you actually build it. It's also a 3-star Fitwel certified, another measure of human health, and it's also a zero energy building. So a lot of experience that we gained in developing this building about how do you really create something that's good for people and good for the planet. And a lot of times people will ask me, well, how did you justify the cost for that? For example, how did you justify the cost of building a zero energy building? And they'll ask me how much, what the payback period was. And I honestly have to tell them I don't know, because that was never really a consideration for us. You know, we didn't take out the calculator before we decided to do this project and say, okay, should we or should we not build a zero energy building? We actually made the decision that we wanted to build a zero energy building at the outset. And then we pulled out the calculator and said, okay, now what's the most cost-effective way to achieve zero energy? So there's a fundamental difference there about when you decide to bring costs into the equation. And it comes down to this idea of how do we measure success? And in this country and most of our societies today, we really use something that's called the return on investment, or ROI. And there's a lot of that's the most popular way of measuring success. You know, how quickly, if you put $10,000 into a particular system, how quickly is it going to pay you back? You know, is it going to take 2 years, 3 years? And quite often, the shorter the time period, the higher, the more weight is given to that particular type of process. I would like to compare that to something called the OKR, which is objectives and key results, which is a very different way of looking at how you measure success. ROI really only looks at direct costs, and it only looks at the costs that it's actually going to take to achieve what you want to achieve. In OKR, we actually can start to look at what are the things we value. So, for example, if you were comparing a project where you were using ROI as your measure of success, you may not consider things like, is the building going to be zero energy? What is going to be the impact on air and water? Are there any toxic chemicals in the building? What's the impact on the habitats around the building and biodiversity? Are you not using fossil fuels? Whereas with objectives and key results, you actually decide what are the things that you value. And you actually decide that those are the things that are going to be important measures in success for your project. And then you actually start to make the decisions for your project that are actually going to support those values. So it's a really major fundamental difference in how you look at things. You know, like I said, the traditional way with return on investment only looks at direct costs. OKR actually lets you look at both direct and indirect costs. And that's actually the type of system that we use at Phipps Conservatory in trying to decide what kinds of projects that we're going to do, which allows us to achieve many of the things that we value in our way of thinking. Another really important consideration is taking the long-term view. Again, particularly when we use return on investment as our measure of success, we are very much focused on trying to get our payback as quickly as possible, and it really leads to short-term thinking about what makes you focus on first costs and actually try to figure out how can you get your money back as quickly as possible. But I think it's really important for us to really start shifting the way we think and think about what are the costs and benefits over the long term. And I think when you start to look at it from over the long term, you see that that's where the greatest value lies in developing a project. There was a study that was done by the Packard Foundation back in 2002, where they decided to look at the cost differences between market rate buildings and various levels of LEED buildings, as well as the Living Building Challenge building, which actually hadn't been launched at that time, but they had some of the preliminary information of what was going to be required. And they wanted to understand what the difference was in the first costs, what it was going to cost to actually produce that building. And then they wanted to look at what the actual cost was going to be over the long term. I'd like to compare the market rate building to the living building challenge building. And the living building challenge building, of course, is the most building that meets the highest standard for energy efficiency and human and environmental health. It's actually the most rigorous green building standard. It actually results in buildings out of zero energy. And when they compared the upfront and design costs, you can see in the second column that a market rate building would cost $12.6 million in this particular scenario. And a similar building built to the living building challenge building costs $16.6 million. Now, most people looking at that who use ROI as their basis for making decisions, they would quickly jump to the market rate building and say that this was the best choice for them to proceed with. But if you actually carry out what is it going to cost to operate that building over the next 30, 60, and 100 years, you can see that a market rate building costs significantly more than a living building challenge building, about $320 million over the next 100 years. Now, as a leader of an institution that's building buildings, I can tell you that even though I won't be around 100 years from now to actually see the benefits of building a living building challenge building, I at least know that I would much rather see my organization over the next 100 years use that additional $320 million to focus on programs for the community rather than be using it for maintenance of a building and producing a lot of pollution and spending a lot of money on operating costs and energy costs. And then this is only looking at direct costs. It actually doesn't look at the fact that the living building challenge building contributes very little to pollution of water, air, and with the extraction and burning of fossil fuels compared to a market rate building. So there's significantly much greater benefits to building a living building challenge building compared to a market rate building over the long run. Another thing to think about is the fact that when we want to think about changing our way of how do we measure success, I think we need to think about how do we view the world and what's the lens that we view the world with. And one such lens that I think is really attractive is this idea of regenerative thinking, where one starts to think beyond sustainability to embrace embrace an interconnected dynamic relationships or view of interconnected dynamic relationships and capacity building. And I'd like to refer to some of the work that was done by Carol Sanford, where she talks about these 4 different paradigms for interacting with the world. And the first model she talks about is called the extractive model or the exchange value model. And this is the model that most of us in the Western societies use for how we look at the world and how we operate. We tend to see the world as fragments. We're focused on it's about me. Quite often we don't think about, or maybe we don't care about who we heard or what we heard in the process, as long as we get ours. That's what we're really focused on. And it's this idea that the world is full of resources. Let's take what we need and let's not worry about what happens. And like I said, that's the way most of the societies work these days. Actually, it's interesting, if you think about taking this to an extreme, this is where you start to get things like colonialism. The next model she talks about is called the less bad model, or the arrest disorder. And in this model, people still see the world as fragments, but now they're trying to stabilize them. And it's not just about me anymore, it's about us. It's about starting to see some interconnectedness, and we're just trying to be less bad. And if you think about it, this is where the environmental movement started, with this whole idea of reduce, reuse, recycle. How can we start being less bad? How can we start causing less damage in the things that we do? The third model she talks about is called the do-good model. And in this model, people still see the world as fragments, but now they're trying to improve them. And it's about us. They're starting to see there's some reciprocity, and they're trying to figure out ways to actually make things that are actually good. Now, you may look at this model and you may say, well, that sounds like a really good model for doing things. But the problem with this model is it doesn't recognize the fact that we're all different. Each person's different. Each community is different. Each culture is different. Each country is different. And we have different needs, and we have we each have our own different essence. And what works in one place may not necessarily work in another place, and it may not be the best place to doing something like that. So having a model where somebody decides what's good and tries to tell everybody else that this is what you should be doing. Just really doesn't make a lot of sense. The last model she talks about is called the regenerative model. And in this model, we don't see the world as fragments. We see it as wholes, and it's made up of all these individual wholes that are nested within each other. So we have lesser and greater wholes, and they're all interconnected. And it's about us, it's about relationships, and it's recognizing that everything is connected, and anything we do anywhere is going to affect everyone and everything else. And it's really trying to figure out how can we maximize those connections and those relationships and continue to do things that recognizes the individual lessons of every one, every species, every individual within every species, every place, and how can we actually continue to do things that allows all those each of those individual entities to develop their own capacity. And this is where I think where we're trying to operate from at Phipps, where we're really trying to understand how can we actually understand the unique relationship we have with the place that we have here in Pittsburgh and Phipps, with our community, with our bioregion, the ecology of our site. How can we actually start to work with developing those kinds of relationships and make decisions that are beneficial to all of those different relationships? So when we have something like a regenerative view of the world, and we start to use this as the lens that we're thinking about things, we actually start to see how can we maximize those relationships and create those values, which we then base our decision on meeting those values. And we don't focus, like you see over on the far left in the extractive model, only caring about how quickly we're going to return on our investment. We're really focused on how quickly can we actually improve and meet the values that we think are important. And that's the model we like to use at Phipps. And I think that's the model that I think I would like to encourage you to think about as something that maybe it makes sense for you to look at your projects this way as well. Now, I'd like to go back to this idea of not using return on investments as a model for the way you do things. And you probably say to me, well, that's not going to work. I'm in a car work. That's the way we make decisions. I have a board. That's how they like to see decisions made. I can't imagine ever making a decision that's not based on a return on investment. Well, I would like to suggest that it's quite possible that you already are doing it. Or if you're not doing it yourself, you probably know people that are doing it. And I'd like you to consider, for example, if you're building a project, or if you're working on a building or ever built a building, or you're actually aware of some buildings that are going up around you. And if you look at those buildings, you'd probably see that quite a few of them probably have some very nice fancy atriums, lots of glass. Maybe there's some exotic materials in there. There's really some fancy tiles and stonework and maybe some exotic woods. And I would like to ask you, and then you might ask the people who are involved in that project, how energy efficient is your building? And they would probably tell you, well, we looked at it and we couldn't afford heat pumps. So we decided to, the return on investment was taking too long. Well, what's the return on investment for the fancy atrium and all the glass and all the exotic materials? So here you can see that people are actually making decisions based on things that they think are important, where the return on the investment is really not that critical. How do we get people to also start to look at things like energy efficiency and put it at the same level as some of these other things that they're valuing? I'd also like to suggest that each of us in our own individual lives are making decisions based on values where we don't use the return on investment idea. For example, I'm sure many of us have cars. And if you think about what is the purpose of a car, the purpose of a car is to get you from point A to point B. Well, if you were strictly looking at cars from a return on investment point of view, all of us would be, riding in cars like a Kia Rio or something like that. The most, looking at trying to find the least expensive car that we possibly can, because we all know that at 10 or 15 years, that car is going to be worth practically nothing. So the best investment actually is to purchase the cheapest kind of car that we can. But I would imagine if I could see everybody and I could ask you to raise your hands, I'd ask you, what kind of car are you driving? Is anybody driving a really inexpensive Kia Rio? And probably very few would raise your hands. And the reason for that is because there's certain things that we value. Maybe we want fancy interior. Maybe we want a sunroof. Maybe we want a large car, we want a car with a heated steering wheel or something like that. We actually start to say that there are things that we value that are going to help drive our decision, even though adding those to the cost of a car is not a very good investment, and it certainly isn't going to help with any kind of return on investment. And then if you take it a step further, you'll see that many of us actually probably borrow money to purchase that car. And I think it was Benjamin Franklin who said, "I never borrow money to purchase a depreciating asset." He was correct. He was correct in that, because here you can see you're purchasing a car, you're paying interest on that money to purchase that car, and now that car is losing value every year. It's probably one of the worst investments you could possibly make. But we make those decisions sometimes because of things that we value. And I think if I were to ask some of the people who actually maybe just upgraded the heating systems in their homes, what kind of heating system that you put in, and they would say, well, we looked at a heat pump, but it was too expensive, so we went with a lesser expensive heating system because we could, the return on investment wasn't that quick. So you can see there's a disconnect there. Okay, sometimes we make decisions based on our values, and sometimes we make decisions based on strictly on a return on investment. And I would suggest to you, particularly if you value things like biodiversity, if you care about climate, if you care about habitats, we really need to start taking those values and actually making decisions that reflect those values, and switch our idea strictly from a return on investment point of view to one that values what our objectives are that are related to what our values are. So I want to leave you with that as something to think about as we go forward. And now I'd like to turn it back to Andrew, and I guess we'll go into the question and answer session. Andrew.
All right, thank you so much, Richard. That was great. All right, yes. So at this time, we'll open the floor now to questions and answers. You can feel free to use the Zoom chat function to enter any questions that you have for our speakers, and I'll spend the next few minutes moderating our Q&A. So I'll kick it off with a practical question for either Vince or Richard. So many of our cultural institutions are in old or historical facilities that use fossil fuel combusting equipment for heating and cooling. So where do these institutions get started to eliminate all on-site fossil fuel combustion, and what are the priority focus areas to tackle first, which can have the greatest impact?
Sure, I'm happy to take that to start. And then Richard, I'm sure you've done beyond the new building, some renovation work in some of the facilities at Phipps you could speak to. A lot of the times in some of these older buildings, they were already designed to handle quite a bit of climate disruption, heating and cooling. They were designed differently than modern buildings. Modern buildings sort of became tied to our mechanical equipment as a way to make it through things. Now, that said, there are certain significant barriers in terms of sort of like insulation values, or even upgrading of electrical boxes in order to have the right voltages to have some of these things. And you can't necessarily, put every system in as a one-for-one. So I would first start by recommending speaking to a design team. That's both architects, mechanical engineers. Sometimes the structural engineers might be required in order to make certain improvements into the building's structural systems. But these are professionals in general that are trained in renovation. And as I mentioned, half of the design work now from architectural buildings is renovation projects. So they're familiar with all of these systems, and it's actually they're kind of excited about these kind of design opportunities. Now, many cases, you'll have to find particular systems that can replace the fossil fuel systems in the space. So depending on how it was done. But I would just stress, this is back to the point I think that Richard brought up. It's not just about removing the fossil fuels, right? Obviously, you have certain requirements in your facilities, not just for comfort, but humidity, natural ventilation. These particular pieces require an interdisciplinary focus. And in many cases, you'll find interesting solutions that aren't necessarily just swapping out for a non-fossil fuel system. And we have to be concerned about efficiency too. There are folks that will just, going back to that lowest common denominator of cost that Richard brought up, you could switch out from a gas system and do a really inefficient baseboard heating system. right? And that's not going to improve your energy bills, and even if it might get you off fossil fuels. So, you really have to consider the systems in place and your particular needs, and the best folks to do that are those professionals that are licensed to do so.
Yeah, thanks, Vincent. I'd like to say that, we actually have had some experience in this particular area. We have an old public works building on our facility that was built in the 1960s. It was actually a pretty ugly cinder block building, very few windows. We actually renovated it to achieve Live and Building Challenge status. So it's a zero energy building. It actually makes more energy than it uses each year. And so it is possible to take some of these buildings that are very inefficient and actually retrofit them to be improved. Right now, we're looking at our old conservatory, which was built in 1893, single pane Victorian glass house, and we're looking at how can we bring that to be a zero energy building, and that's probably the biggest challenge we've ever faced. It's because it's probably the most inefficient building ever built. But I think there are things that we can do to, and as Vincent said, if hiring the right professionals that can help you take a look at the facilities and really determine what are some of the most cost-effective ways to make that happen. But again, the key thing is set your value, set your intention of what it is you want to achieve, and then seek out the people that can help you achieve it.
And I'll just add one more thing too, Andrew. This is an important topic. There's a movement. We sort of started talking about energy efficiency, operating emissions, and then about 12 years ago or 15 years ago, there's a conversation about the embodied carbon that I mentioned, the materials, the extraction, manufacturing, operation, disposal piece, that whole life cycle of the material. And then now the conversation is this idea of a whole life cycle for carbon for a building, let's say. And that looks at all of those things put together. And this is really important, especially around retrofit, to recognize that some of the materials you might use or systems you might use might be very carbon intensive to create. And you're sort of having this time value of carbon question, where it's like, am I putting in more emissions in the creation of, let's say, a kind of insulation to make sure my building is more efficient and comfortable, of course. What other options are there for that same kind of outcome, back to the objectives that Richard's talking about, to still have the energy efficiency, still have the comfort, but for finding a different solution that might not be as carbon intensive in its manufacturing and creation. And so looking at what kind of benefits are you getting in the operation based off the amount of emissions you might put into the material. So there is a concern, I think, that this renovation wave that I mentioned is going to have a lot of high intensity material development, and we're going to burn through our carbon budget, and we're not even going to see the benefits of the efficiency of the building. So we really have to be concerned with both sides of that equation.
Those are great answers from you both. Thank you. We had a question come in from the chat. I think this one will be for Vincent. So James asks, I've read some conflicting articles concerning gas versus electric, and some of them suggest that the production of batteries and disposal the risks outweigh the benefits of reducing gas-based emissions. Can you offer some clarity on this point?
Sure. I'll first offer that there's a variety of reasons to get off of what's called natural gas, also called fossil gas, in buildings. Particularly, we've given essentially a social license to allow for combustion in buildings, which also contributes to significant health impacts. So most of the movements that you see have dual benefit of moving away from gas, not just on, just go back to Richard's, what do you value? And if you value the health, particularly young children in closed environments, they've actually linked gas cooking in the home, for example, to asthma at a pretty significant rate. So there's multiple values in this. But to the point of the question from James is that electric batteries are not necessarily required as a part of a system shift from gas to electric systems. Now, you have to ask, where is your electricity coming from, and can you withstand both peak changes in the electricity grid, usually in the afternoons when everybody sort of comes home and kicks on starts cooking their macaroni and cheese for their kids and starts heating up their buildings. There's that peak load in the day, and then there's also seasonal issues where, when the sun is actually lower in the atmosphere, we get a little bit less solar radiation in the winter. The wind might not blow all the time. That's when you have batteries sort of on the utility grid scale. And I would offer that most of the battery technology work is for our phones and for our vehicles. It's sort of this quick in and out. We got to charge it up as fast as we can, and we got to let out the electrons as fast as we can. Buildings are a little bit different. There are those peak loads, there are the seasonality loads, but we can look at different forms of storage that may not be available for vehicles and for our mobile devices. There are very simple solutions. We think about hydroelectric systems. We're essentially running water downhill. We're running it through a turbine. Can we use this for those peaks? Can we look at using the sun's energy and the wind's energy to pump water back uphill? And then when we need it, we bring it back down. There's ideas of doing that with a train and looking at the potential energy of regenerative braking to create electricity. There's even ideas of sort of stacking shipping containers. And then when you need the energy, then you drop the shipping container, and the potential energy of that can create electricity. So I think we need to stop thinking about this sort of immediacy of some of these solutions and these high-tech extractive sources, and think about some more low-tech abilities for buildings, particularly because we're talking sort of about different systems for different applications. So batteries are one solution to those seasonal and peak storage, but they're not the only solution. And particularly with the electric grid, it's about inputs in and inputs out. We have to use it at the same time. So it's trying to shift that load, and energy efficiency can be a really great strategy to support that, where we don't actually need as much of the electricity from those renewable sources. So that's particularly on the battery question, but I'm happy to talk more about the gas to electric conversion movement.
That's great, Vince. Thank you so much. All right, we had a question come in from Kate for Richard. First off, amazing talk, Richard. What, if any, climate set points do you use for the internal environment of the living building here at Phipps?
Very good question. We feel that it's very important for people to be comfortable. And so we set our temperatures, I think, around 70 degrees for 69, 70 degrees for heating, and around 72 for cooling. And I know a lot of people, when they start thinking about building, thinking about efficiency in buildings, their engineers will try to convince them, though, you need to be up to 76, 77 in the winter, summertime, and 67, 68 in the wintertime. Just, encourage people to wear sweaters or something like that. That to me is the wrong approach. If we want people to adopt these solutions that we're talking about, we have to make sure that they see it as something that's better. People don't aspire to be uncomfortable. They aspire to want to be comfortable. So we need to make sure that the solutions we offer them are actually better than what they have now. And I think you can see the building in the background behind Andrew is the Center for Sustainable Landscapes. That's an incredibly comfortable, wonderful building for people to be in. And I think that's a really key thing. We need to show people that these solutions are beautiful and they're better than what we have now. And providing comfortable spaces for people I think is really critical. Because like I said, nobody wants to be uncomfortable, and we're not going to get people to adopt this way of thinking or moved in this direction if they see it as going backwards, not going forward.
Thank you so much, Richard. And thank you, Vincent. So I think we'll call it here. I want to thank everybody for attending this Climate Toolkit webinar. Very special thanks to Vince and Richard for joining us today and sharing your presentations. If you have additional questions that were not addressed, please reach out via email and I will relay them to our speakers. A recording of this webinar will be made available to watch and share along with a PDF of the slide deck, and we will send those links to you all in the coming week. So thank you again for tuning into this Climate Toolkit presentation. We look forward to connecting with you soon, and thank you and have a very wonderful rest of your day.
Thank you all. Thank you very much for having me.